Ladies and gentlemen, let's gaming.com video. Let us revisit the Xbox One's hardware specifications, especially the ESRAM. It has been confirmed that the new upcoming title, Project Cars, is actually using the Xbox One's ESRAM for deferred render targets. We'll go into what those are in just a moment. And the developers have stated that careful use of this actually mitigates some of the PlayStation 4's unified memory advantages. So in case you're not familiar with the game, it's pretty much coming out to every platform under the sun, including the Steam OS, the Wii U, the PlayStation 4, the Xbox One, and the PC. As the non-Steam OS version of the PC. And there's been a lot of confusion and opinions on the Xbox One's ESRAM. I'm pretty sure most of you are aware of it by now, but I'll quickly go into it in case you're not too familiar with how it works. If you're not, you can type in ESRAM on the channel and you're going to come up with a crap ton of information. So basically all the ESRAM is 32 megabytes of very quick amounts of memory, which is basically on the die of the AMD Jaguar / GPU amalgamation known as the APU. In other words, the main heart of the console. This is to make up for the lack of bandwidth offered by the Xbox One's DDR3. Andy Tudor, who is one of the developers of the game, has stated, and I quote, "Our engine uses a light pre-pass style rendering approach, and after experimenting with a number of different variations, we found it was more efficient to use ESRAM to hold the deferred render targets. Careful use of the ESRAM like this for various render target stages mitigates some of the advantages the PS4 has with its faster unified GDDR5 memory." You also further added onto this that there were a number of factors that influenced the move. Firstly, the power of the next-gen consoles allowed games to be showcased as it was meant to be seen, and the pipeline and architecture of the new machines makes the development process easier. We see the sharing feature on both consoles are extremely engaging for players. The ability to self-publish is appealing. The retail space for the last-gen games will slowly dwindle over the next year. And also, given our timeline to launch, there will be better balance of number of people out there in the mindset for next-generation gaming compared to those still playing their existing consoles. So overall, there will be a number of contributing arguments that indicate it is the right move to make for the next generation rather than focusing on the Xbox 360 or the PS3. So what exactly is deferred shading? Well, or deferred rendering. It's a screen space shading techniques, and the reason it's known as deferred is because shading isn't actually performed on the first pass by either the vertex or the pixel shaders. What instead happens is that it's actually done on the second pass. So what happens effectively is the first pass, things such as the positions, how large things are, the materials for each of the surfaces are rendered into the geometry buffer, and much more besides is done. And then a pixel shader computes the direct and indirect lighting, and then it will determine that and then put the whole thing together. Now this does have multiple advantages, including this memory usage and also the ability to render more lighting, for example, on a screen. It allows more easier management of complex lighting resources. And quite a few titles have used deferred lighting as well in commercial titles. We have games like Crysis 2, Dead Space, and even Infamous. Now, just to be clear, deferred lighting, also known as light pre-pass, is actually a different version of deferred shading. This one instead uses 3 passes instead of 2. The first one, of course, will be the geometry, as we've just discussed, which will be things such as the size and the shapes and all of that other jazz. Then the next one would be the attributes necessary to compute the actual per pixel lighting, because obviously it has to do it on an individual basis. And then finally, the screen space is deferred again, and then the pass outputs what's actually been created. It reads back the lighting data and outputs the final pixel shading. Now, there are advantages to this. The primary is that it actually reduces the size of the G buffer, the graphics buffer. I'm sorry, not graphics buffer, geometry buffer. There are a lot more besides, so you can Google around if you do want to know more about deferred shading, but let's continue to venture forth in terms of this video and the PlayStation 4 and the Xbox One. So, it's been known for a while that the Xbox One is going to have problems with various rendering techniques, primarily because when you start to add in multi-sample anti-aliasing or anti-aliasing as a whole, you're using a lot more memory up on the console. And render targets and so on, when you're actually rendering a frame of animation for the screen, it can get pretty damn large when you're dealing with a 1080p image. Obviously, if you're going slightly below that, then you save a lot of memory. But there's of course been those concerns that with 1080p and 60 frames per second, the Xbox One's memory is just not there. It just doesn't have enough memory bandwidth or GPU computing power. So if there are ways around it using the ESRAM, and this is the key, I think, for the Xbox One, it's going to have to be smart. It's going to have to be crafty in terms of the usage. Now, what we do know in regards to the Xbox One is Microsoft are still fairly early on with their tools. No doubt a lot more of this is going to become automated over time. In other words, the developers are going to be able to see just what's going on with memory usage and so on. From what we've heard from leaks, a lot of it so far is still manual. So you have to manually flush the cache, you have to manually tweak the usage of the DDR3 as well as the ESRAM, which means that it's not quite so smooth to develop for as, say, the PlayStation 4, where all of its memory is created equally. Regardless, if developers can learn to implement these type of techniques, it's just going to mean that the game is going to run smoother. It's going to mean that we're going to get nicer looking titles, higher resolution, and we might be also able to implement different or more advanced forms of anti-aliasing. Obviously, in some cases, some of this is going to be limited, for example, by the amount of ROPs that the Xbox One has, which of course are the raster units, which are pretty much responsible for the final creation of the scene, and they add in shiners. So, for example, they could add in things such as texture filtering or anti-aliasing. And so, because the Xbox One only has 16 versus 32 of the PS4, that can be somewhat costly. But it's certainly going to be a huge bonus if developers can get around the limitations of the Xbox One's ESRAM. As far as we understand it, the memory bandwidth of the Xbox One's ESRAM is not a problem. In other words, it has more than sufficient amounts of memory bandwidth. It's actually the space that's the problem. The reverse is true, however, of the system's main memory. It has plenty of space, but bandwidth is the problem. So you've got that balancing act that you've got to constantly juggle. Regardless, hopefully you've enjoyed the video, and it's certainly some food for thought. I'll see you soon. Take care. Bye for now.